Okay. We are going to finally use this book today. I brought some copies of what we're going to do in case you don't have the book yet. So try to get this soon. Or like I said, you can go into Canvas and print out each module as we hit it. Just don't forget that the order of the modules is not the order that we're going to cover them in. I thought I had, oh man, there they are. So for example, this is module 1, that's functions, and then module 4 and 5, oh that's right, module 4 and 5. 4 and 5 are about more about functions, behavior, function, and more about functions, yes. So 1, 4, and 5 are all about functions. So we don't do them completely in order. I do it based off of the textbook. Okay. Does anybody have questions about how to find the homework? Is everybody cool with? Has everybody managed to find the homework?
It doesn't work on supply.
Okay, I'm sorry. Yes.
Is it in this or is it?
That is not the textbook.
So you want us to print out the pages like from the pages?
I am not the textbook. No. Just to make sure everybody can find it. So if you go to modules, right here, you can either do the PDF of the textbook, or if you click this one, you can order a copy if you want to. Don't pretend like you're a bookstore and buy 50. That'd be silly. Buy a print copy if you want to. It's like $40 or whatever if you can get it black and white. Or you can view it online, or you can download the PDF. And then if you want to find the homework, you like 1.5 homework, you go to 1.5 and you go to the end. It's crazy. It's like the olden days. Okay. So right now, we still have to finish up a couple of factoring things, but you could have gone in and started doing the factoring homework. If you didn't, you're fine, because when is homework late? Yeah, if you try to turn it in after the day of the test, yes? Then it's late. Okay, so you have time, but you never have time. Right, so you should probably get in there if you haven't gotten in there yet. Any questions from homework? I do have one problem I'm going to do here, but are there any other questions from homework?
It's every 5 minutes, so it'd be like 5, 10, 15.
Let's see, whatever it says here.
It says 5 or less.
Yeah.
Okay.
So just to make sure everybody can read this correctly, the 1.5 homework would be 5, 10, 15, 20, 25, 30, 35. And then 37, 38, 40. Yes?
Yeah.
Cool. I just hate when I would get homework from teachers, then it was this like long string, so I try to do E50 or E30 just to quickly throw problems at you. Yeah. It almost doesn't matter which problems you do. It's just the practice that matters. Yes?
So how do you recommend that we kind of pace ourselves through the homework? I mean, we should just do what we know how to do, basically.
So this is why I give a soft due date. The hard due date is the day of the test. Turn it in after the test, that sucks. But still turn it in, dear God. Especially if it's not very late, right? If you turn it in late, your possible highest grade starts to kind of slip, yes? But the sooner you turn it in, the better. You with me? You could still turn in section 1.5 homework on the day of the final. It is incredibly late. So it's not going to be worth as much as it would have been if it was on time, but it would still be worth more than zero. Okay. What's the soft due date? Does anyone remember the soft due date? It's on the syllabus. If I finish lecturing over a section, so today I'm going to finish lecturing over 1.5. 2 classes later. So what's 2 classes later after today? Tuesday, Wednesday. So next Wednesday, you should have 1.5 homework done. If you have it done before then, celebrate, right? That kicks ass. If you don't have it done by Wednesday, is that the end of the world? No, because you still have time till the day of the test. So okay. So the soft due date is just so you have a way to gauge if you're on track. And the hard due date is because we're humans and you need a hard due date. Anything else about how that works, or any questions about actual problems? Either one. All right, so I do have one question I want to address. It's a good one. So for homework, you guys have to do number 45 and 48. Is anyone concerned? Yeah, what's trippy about this? There are fractional powers and negative fractional powers, yes? Okay, so let me go over this kind of problem. Did I start recording that sucker? Let's see. Yes. All right, so guys, help me out. How would you factor this?
Start taking the 2.
Can you take a number out?
X.
Yeah, you can't take any numbers out, right? Because one has a 2 and the other one has a 1. They have nothing in common, except for 1, and that doesn't matter. How many x's can you take out? 2. Right. Can we generalize that? Wouldn't you just always take out the smaller power? Does that make sense? Why do you want to take out 2 x's?
Because
Then you get 1.
Because if you try to take out more than 2 x's, because he can give more than 2 x's, right? It's good for him. But if you try to take out more than 2, he's going to freak, correct? He's going to freak out. So we can generalize that. I always take out the smaller of the powers when I have like bases. Does that make sense? Okay. So this would be... Oh yeah, I'm sorry. So if I take an x squared out, those are gone, so there's just a 2, and then what do I have left here?
X cubed.
Good. I had 5 x's, took 2, so I got 3 left. Yeehaw! So what about this weird ass shit here? What generalization did we just realize that will help me out here? Do they both have some number of x's? They don't both have numbers in common, do they?
No.
Okay. But they both have some number of x's. And what did we just say? If they have the same base, how many do I take out? How do I tell how many to take out? Right, we just said it. Yeah. The lowest power. What's the lowest power on the x?
2.
Negative 2. That's what I'm going to take out. No. Almost. I'll show you why. Why was there x cubed left here? Because when I take squared out, what do I do with the powers?
You also take.
I subtract them, don't I? Yes?
You add them.
So let's get there. Is everybody with me? Because when I multiply it back in, I would add powers. So when I distribute it out, I subtract powers. That's how we got 3 here, because 5 minus 2 is 3. You with me? If I always want to take out the lowest power, I want to take out x to the negative 2. This is easy. What's left if I take out x to the negative 2? What's left in this term? 2. Thank you, term. Now this is where people freak out, and I don't blame you. When I take this out, I have to subtract that power out, yes? So it's not 5 minus 2. It's 5 minus negative 2. What's 5 minus negative 2?
7.
5 plus 2, 7. Yes? I always think about this. If somebody takes debt away from me, don't I have more money to play with? So when I'm taking a negative power out, I always think of it as taking debt away. Shouldn't the inside get bigger then? Do you agree that this looks better than this did? It's got no negative powers. It's only got one term with an x on it. So there's a few things going on when you're factoring. You kind of want what's left over to be nicer than what you started with. And if you always take out the smaller power, that will happen. Can we stop for a minute? Somebody semi with me so far. What have we learned so far? When you have like bases, so many x's, so many whatevers, you take out the smaller power. Yes?
Yeah.
No matter if it's negative powers in there, no matter if it's fractional powers. Now, a little side quest I can go on. Do you guys know what fractional powers mean? Have we talked about that yet?
Kind of.
We did? Kind of? What's the square root of 9?
3.
3.
Why?
3 times.
What's the square root due to 9? So if I say y is the square root of 9, 3, you would say because 3 times 3 is 9. But if I ask you, what is the square root due to 9? The square root of 9, it cuts 9 in half multiplicatively, yes? Now stay with me. Stay with me. You guys are gonna be, oh, you're here. Oh, good. You're early. It's okay. Stay with me. That's almost perfect.
Will we outside?
No, you're good. We'll come right back to this because I haven't gotten too deep into this. And this is Jesse. Sorry, Jesse. I didn't mean to leave you out. I'm going to let them take over. I warned most of you guys that we had some guest speakers coming. Jesse's going to use the computer to throw a lot of information at you. Jesse's the new student success office liaison.
Yeah.
And Nick, you're still working as are you a success coach?
Yeah,
Yes.
still am, yeah.
Good. Sorry, I didn't mean to imply that you should have been fired.
Yeah. Well, who knows?
They're gonna tell you about the office and what they can do for you. I'm gonna stand over here. I'm gonna sit down.
Oh.
How's everyone's first week going? Good. Going pretty good? Nice. Has anyone heard of our office, the Student Success Office? Yeah? Okay. It's cool. Has anyone used our services? No? Okay. Well, it's good because new information then, so don't want to be giving old information all the time. Oops. Is that,
Yeah, I don't know. It's a little messed up on the first slide.
that's okay.
Oh, you mean here? Oh yeah,
I
I
don't
saw
know.
that this morning. It's okay. Technology. I'm trying to see if I can get that monitor over there to turn on. And I made it worse. No. Now 2 monitors don't turn on.
In the meantime, I'll pass out some of our.
Yes.
Okay,
Hey,
we're
I'm
good.
gonna leave it. I'm gonna
Yeah.
leave it.
Okay. So
close
my
enough.
name is Jessie Sauter. I'm the Student Success Liaison at the Student Success Office, and we're going to teach you all about what the Student Success Office does. This is Nicholas. He is a coach at the Student Success Office. I'm actually going to have Nicholas tell you about our services, and then I'll jump in at the end. So take it away.
Yeah, so as Jesse mentioned, my name is Nicholas. I'm a student. I'm also a student worker as a success coach. So what we do as success coaches is we meet with students. So we meet one-on-one. We help with time management, note-taking, exam prep. One thing I like to do is at the start of the semester is get a game plan going. So you can meet up with us and we can actually, look at your schedule, look where you have openings for studying, openings for, life and enjoying your life and all that too. And then to kind of like plan a whole, semester game plan just to get it going and kind of have a flow for it. So that's kind of our academic mentors. You can schedule in person or Zoom. And then we also have this is an elementary class, math class, correct?
It's 171. It's the new innovative path to calculus, like a pre-calc.
Oh, okay, cool, for sure. So I've taken calculus, pre-calc, actually with Professor Waller. So yeah, we're not tutors necessarily, but we can connect you to those tutors. We also have skill building events, such as workshops, time management workshops, note-taking workshops. We also do a study jam twice a semester typically. So one in the fall, one midterm and one final study jam. So it's kind of where you can, chill out, study, and just get ready for those exams coming up. And as I mentioned, also connecting you guys to resources as well, because there's plenty on campus that you may not be aware of. So yeah. Like as I mentioned, some of the things that we do, learning from our tips that we provide, etc., time management, note-taking, exam prep. And then this is an event that we got going on today. It ends at 2 p.m., so if your class is done, before 2 p.m., you're able to pass by, grab some tea, grab some cookies. We also have a workshop series presented by Health and Wellness. They have a time management workshop. They have, I believe, stress management and mindfulness practice workshop as well. So you can scan that QR code if you'd like to join that. And then there's a way that you can contact us. If you scan that QR code, you can actually schedule an appointment for whenever you're available. You can schedule an appointment to meet with one of us, and we can help on whatever your needs may be. You can also email us. You can also call us or text us. And yeah. Any questions?
There's a lot that they said.
Yeah. You
To me,
can-
it only makes sense. It's the most common sense position on campus is success coach, because Grossmont has so many resources for everybody, and you never know what resources we might have. So these guys are trained to know all of the resources. They listen to your situation and they connect you with the right places. It's insane.
Yep.
So whatever situation you find yourself in, just contact these guys.
And we're all students, like we're student workers, so most of us are getting prepared to transfer. I'm actually transferring next fall, and so we kind of been in your place. We kind of know, the struggles. We've seen it all. I guess is the best way to say it. So, maybe we've been in those actual classes that you're taking currently, and so we know kind of the process and what how you can succeed. So that's why I feel that's why we're very helpful in that case. And it's free too, we're not charging unless you want to pay extra. We don't. I don't mind, but maybe it's not allowed. But
Thanks, Nicholas. So I like to think of the Student Success Office as like a one-stop shop, first point of contact. Something happens, you get a weird email from Grossmont, you don't know what it means exactly. Reach out to us and we will help you decipher it. We will figure out what you need, and if we can't provide what you need, we'll connect you to who can provide you with what you need. And we're not going to say, oh, go to financial aid. We're going to actually connect you with a person in financial aid to make sure you get what you need. And that might be, like Nicholas said, that might be academic support. So you go to tutoring to get support for math and science. You come to us if you want support for time management, scheduling, study skills, note-taking, etc. So I don't want to take too much more of your time because I know you have a busy class going on, but yeah.
Explain one more time what that middle phone number is.
this one.
Okay, so okay, I wasn't going to do it, but I'll do this one. I like to do this, students don't like it, but I like to double dog dare you to take out your phone and to save this number. It's a text. You can text us. You can text us and say, I didn't do as well as I'd like on this exam. I have no idea why. I thought I studied really hard. Can I talk with you about it? Or you can say, I just ran into my friend and she said that she hasn't eaten in 2 days and she doesn't know what to do. You could text us about it. All kinds of stuff. So who did it? Who put it in their phone? Brave, brave, brave. Okay, brave. Thanks for being brave. Any questions before we take off? Okay, we have brochures. Take one. And we are drop-in too, so you can just come by our office. We are in the Tech Mall. Does anybody know where the Tech Mall is? Yeah? It's by the library. It's with the library. Tech Mall, second floor in the Village. Somebody's always in that office 9 to 5, so if you want to, well, except for Fridays, we close at 1. So if you want to come hang out, get a cup of coffee, ask some questions, we're ready for you. Thank you so much. Any questions? Questions?
Nice.
Oh, thank you.
Thanks, Jess.
Flyer.
Oh, good. I recorded that whole thing, yay.
Okay, I'll see some of you next week in my office.
Thanks, guys.
Bye.
By the way, that's Brandy back there. Brandy, in case you're curious, she was in Jesse's position before, and Brandy has moved laterally to a different position. What exactly are you now?
I now serve as the supervisor for all tutoring on campus.
Oh, that's right, you got Nikos. You guys gotta
Yes.
remember, you got Nikos.
Yeah, so intros, I'll run into you at the Math and Science Center right down the hall right here, but also know that we have tutoring located located on the first floor of the Tech Mall, in Building 70 for any class that has a writing assignment. Think of it that way. They also support world languages, American Sign Language, ESL. We have some econ and accounting tutors coming soon. If you're enrolled in any of those CSIS classes, there's tutors for that in Building 70 on the first floor. But definitely, I'm sure Jeff will take you to Math and Science Center, check out the CISL and everything. But know that there's other places here to help you with the other classes that you're enrolled in.
Sweet.
Yeah.
Great, thanks guys. Good to see you, Nick. Yeah, take care.
All right. Yeah, Nick especially knows your struggles because he had me there, so he has specific knowledge. Okay. So coming back where we left off. I'm not sure why that poor little monitor. It just won't turn on. Okay. Poor little guy. So if you're sitting over there, I'm sorry. You got a monitor on the side of you. Got a monitor behind. I'm always curious if somebody's going to come in and sit staring the other way. You got monitor. You got monitors all over. So everybody's cool with this, yes? Square root of 9 is 3. Well, if I just said, what is half of 9? What would you say? 4.5. Yes. Is that cool? Because if I just say half of 9, you think additively. So what I mean by that is, half of 9 is a number that I add to itself to get 9. If I say, what's half of 9 multiplicatively, you would say 3. Yes? What do exponents represent? What operation do exponents require you to do?
A number
Multiply. So another way to write the square root of something. The square root of something, oh man, you're dead. The square root of something is half of that thing multiplicatively. Now to give you the full rant, I wish we had never invented radical notation. It's dumb. Fractional powers are better. You might not agree with me because you guys haven't used fractional powers as much, but they actually make a lot more sense. Sort of like every other country on the face of the earth uses metric system, except for us. We don't. We're the only country that doesn't use metric system. Did you guys know that?
Yeah.
So if I ask you how long is a decimeter? Hey, yeah. Did I do this already?
Yes.
I did.
Yeah. This, but yeah.
I just. So didn't I already talk about?
Yeah.
I must have. Okay, so that's funny. So I must have done that problem already. All right. You're gonna have to excuse me. So one level is I'm old. I'm an old man, and I've always been absent-minded. So one level of it is I'm just absent-minded. The other level is I'm teaching a pre-calc class next to you guys. So there's a lot of overlap. So I'm like, did I already talk about that? Yes.
Yeah, you did go over fractional notation, or fractional exponents, but you didn't cover this specific.
Oh, this year. Okay,
Yeah,
beautiful.
Probably.
So so the problem you have to do for homework is 45 and 48. Because I'm evil, I'm going to show you how 47 works. So I can leave you guys some stuff to do for homework. Yes? Let me grab myself some papier. Oh, there we go. So I'm going to copy this down real quick, and then we'll do it. Oh, yeah, let me copy it down, then we'll build up to this. You can look at it right there, Jeff. That's crazy. Okay. So we just went over the idea that when I have to factor something and I have like bases, I take out the smaller power, correct? So let me go through step by step. Is there a number that I can take out? Actually, let me do this first. How many terms are there? Beautiful. Is there a number I can take out of both?
No.
I got a 14 here and a 5 there. Do they share any factors? No, right? 5 is prime, and it don't go into 14. So they have no common factors.
Let me ask you a weird question. You all agree that there's not a 7, or not even a 2. There's not a 2 in this. You all agree with me? There's no 2 in this, so I can't take a 2 out. You all agree with me?
Yes.
I love it. Some of you guys are looking at me like, yeah, Jeff, it's a freaking 5. All right. Remember this. Is there an X in this term?
There is no X in that term. There's no X. The same way there's no 2 in that term.
Isn't 5 2 plus 3? Didn't you just tell me there's no 2 in it? So when I say is there a 2 in it, I mean is there a 2 a factor of it? What is the only stuff you can take out? Common factors, yes? So try this again. Is there an X in this? No. There's X plus 2's. Does this also have some X plus 2's? Yes. Do they both have some amount of X's then? Does that have any X's in it? Nope. Right? If I would have written X to the 3rd power here, I could take some X's out.
Okay. Let me stop for a minute. So something I always say to my classes is, does anyone draw really well? Good call. So you see things you draw really well? Anybody else? Okay, I'm sorry. I don't want to single you out if you don't want to be. But I don't know if you could tell from the way I write. I more than likely don't draw. I paint pretty well. Because paint can be impressionistic. Drawing, I suck. I suck at drawing. I don't naturally break stuff down into their geometric shapes. I don't. I think I should be able to because I teach geometry, but I can't. Do you guys with me? I don't naturally do that. Could I take a class and learn it? Hell yeah. It would be harder for me though than somebody who was born with the ability to break stuff down into their parts, yes? Math was easier for me because I was lucky. I break a problem into its parts easier. So when I look at this problem, so if you weren't born with that, you're like, lucky you, and you have to work at it a little bit harder. But the way I look at this is I look at my numbers, nothing comes out. I look at my X's, he's got no X's, so that definitely doesn't come out. My X plus 2's. They both have some X plus 2's. How many can I take out? We already went over this. No? 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 How many of them can I take out? So let me remind you. When we had this problem earlier, how many X's did we take out? 2. Why? Because they both have 2 X's and 2 is the smaller power, correct? Mm-hmm. What do we take out here? -2. Why? Because they both have some X's and -2 is the smallest power, yes? Mm-hmm. What is the smallest power on X plus 2?
-2/5.
That's how many I take out. Now just go with me. I love you guys. Okay. So if I take out the smaller power, and to be nice to myself, I always try to write what I'm taking out a little further, so then the first term I can write what's left there. So they kind of line up. So did I take any numbers out? No. Did I take any single X's out? No. So 14X is still there, yes? How many X plus 2's did I take out? And it only had -2/5. So does it have any of these left? Nope. Continuing. Right? That was there, I took it out, so it's gone. Here, did I take a number out? Nope. How many X plus 2's did I take out? -2/5.
Yep.
So that'll be 3/5 minus -2/5. What's 3/5 minus -2/5? 3/5 plus 2/5, 5/5, 1. So how much is left in that term? A whole X plus 2. The more you understand that this problem is the same as that problem, and you're like, it's obviously not, Jeff. What the shit are you on? Or what should you be on? By the way, I'm not done with this problem yet, but let me show you. Math doesn't care what's in there. The process of math never changes. How do I factor something? I'll look at the numbers and I'll look at the variables and I see what's it got in common. And I take out the lowest power of whatever it's got in common. Yes? That's exactly what we just did on number 47. We did exactly the same thing we did on this problem. We did exactly the same thing. It just looks worse.
Because it's got fractions in it. So math don't give a shit there's fractions in it. We care. But the process doesn't care. It just says take out the smaller power. What's the last thing I can do on this problem? There's something I can do here. A couple things. What do I do here?
Distribute.
Yeah. So you go 14x plus 5x plus 10. So then I get, oh my god, I get 19x plus 10. Chip-a-chow, chip-a-chow. Would you all agree that what's inside here is better than what was there in the beginning? I kind of removed all the weirdness to there. Do you see that? And by the way, I hope you see that the powers are kind of lined up to kind of work with each other. That happens all the time in calculus because of how calculus works. You'll get these powers that kind of fill each other in. You see what I mean by fill each other in?
Yeah.
Whatever I took out made a hole in here. It filled it in. Okay. Is that all right? The more you see that the process we use to do this is the exact same process we use to do this. They're exactly the same process. What do they have in common? What's the smallest power on the variable they have in common? We did exactly the same thing. Took the negative 2/5 out because this is smaller power. Now it gets a little more complicated because they're fractions, but it's the same thing. I subtract it out. Okay, I'm gonna let that go. So that is important. It's not the most important thing, but it is important. Okay. Do you want to do one more of those, or you want to? Yeah? All right, let's see what Jeff can make up. This is always exciting. You can make a problem. Let's see what I do. So if you go step by step, if you break the problem down into its parts, can somebody tell me how many terms there are? 2. Do both terms have a common number factor? Is there a number that goes into both numbers in each term? Is there a number that goes into 8 and 6? Yes. Right? You guys see that? You can take a 2 out. So you just go numbers, and then you go variables. Yes? So in terms of numbers, I can see a common factor of 2. Do they both have some number of single n's?
No.
Nope. Do they both have some number of n plus 5s?
Yeah.
Yes. And how many n plus 5s do I take out? Negative 6 7s. So I'm undistributing. That's why it looks like a number times stuff, because I'm undistributing. So what number is left in this term? What number is left?
4.
Yeah, 8 divided by 2. I've taken a 2 out, right? So 8 divided by 2. 4. Did I take any m's out? Nope. And then how many n plus 5s did we take out? How many n plus 5s did we take out?
Negative
6
6.
7s. So I had 1 7th, and I took away negative 6 7ths of them. So what's 1 7th minus negative 6 7ths? 1 7th plus 6 7ths. Do I have to write this down? Here. So right here, I'm doing 1 7th minus negative 6 7ths. What's minus and negative? Yeah, and what's 1 7th plus 6 7ths? 7 7ths or 1. So in this first term, there's a whole n plus 5. Plus, what? Yeah, 6 divided by 2 is 3. And I took all of these out. Chop. And then what's your last step? Distribute. That is the hardest couple of factoring problems in that section. It looks horrible, but do you guys see? I really hope so, guys see. It looks horrible. It didn't really do that much if you think about it.
It just looks weird. Maybe. See if you guys agree. Now, what's the last step? I'm sorry, you just
Distribute.
yeah.
In this case, I don't have any like terms, so bam. So what's left inside looks a lot cleaner than the original problem did. Yes? Okay, because I took all the weirdness out. Okay. You're going to be doing a decent little amount of this kind of thing in calculus, especially in the early going.
And obviously, in this class, you'll be doing a little bit of this. Anything else from homework stuff before I jump into where we left off? Okay.
Last time we worked on this handout. So was anyone not here yesterday? Before I ask that question, I should have made sure I brought extra. Here we go. Yay! Oh, I think the one extra I have, I wrote on it a little bit. So this sheet was all about factoring trinomials. Just to do an example before we get into new stuff, how do I factor this here? We'll do two quick ones.
What do you ask yourself to do this problem? What do you have to figure out?
Adds to a negative 11.
Yeah, what multiplies to be, what two numbers multiply to be 30, and add to be
11.
negative 11. Yeah. So what does that?
Negative 5, negative 6.
Negative 5, negative 6. So x squared can only be x and x. So when the first number is a 1, there's a lot less work. It's just get the numbers that work right.
When the first number is not a 1, let's do a problem like that.
Yeah, I'll just do this is one I know works, so I can do it really quickly. I like that. 4, 5, 6.
Does anyone remember the first step? The first number is not a 1.
4 times 6 will equal.
Yeah, you got to multiply the first and the last. So instead of finding factors of negative 6 to add to be negative 5, you have to take that 4 into account because it's going to mess things up. Yes? So negative 24, what are factors of negative 24 that make negative 5? Negative 8 and 3. Yes! And then you break up the middle term based on those numbers. So there's an infinite number of ways to break up negative 5, but it's only these numbers that would make the grouping work. Okay. So what comes out of these two? Yep. 4 and... No. What comes out of those two? A 4 comes out and? An x, because they both have a 4, they both have an x. So what would be left here?
X minus 2.
Yeah, there's x, because you took the 4 and you took 1 x away, poor little dude. Here,
Negative 2.
yeah, 8 divided by 4 is 2, and you took its poor little x dude away. What comes out of these two? 3. And then you're left with x
Minus 2.
minus 2. And now what tells you you're on the right track?
Both of the parentheses.
Yeah, these are the same. They have to be the same because you can only take out something that's in both. Since they both have an x minus 2, then you can take it out. In fact, I like to freak people out a little bit. How many x minus 2s are there? They say 2, and I'm like, no, there's only 1. there's one x minus 2 that somebody distributed to, what's left inside of it? Take an x minus 2 out.
4x plus 3.
4x plus 3. Yeah. So we're almost done with that. We talked about grouping, that's 4 terms or more. We talked about this kind of stuff, these 2 problems, that's for 3 terms. So what can we do if there's 2 terms in a problem? Last week. So for example, I think there was a problem like this in the warm-up sheet, but I can't remember exactly. What if I had this kind of problem? There's 2 terms. Can somebody tell me, compared to the kind of problems we were just doing, what term is kind of missing?
Previously there was a middle term.
Yeah, the middle term is missing. So somehow, whatever the answer is, when I FOIL it, the middle terms cancel. Yes? And that's why it's not there.
So there's
So, I need, when I FOIL, I need to get the exact same things in the middle, except they're opposite signs, so they cancel. Does anyone remember how this works? Y squared, how do you break that up?
Y.
Y times Y, yes? 16.
4.
4 and 4. Now you could break up 16 as 8 and 2, but then the middle term would never cancel because they would never kill each other. They have to be the same, so they die. Poor little dudes. Yes, one of them's got to be negative, one of them's got to be positive. Doesn't matter which one, because now you see the middle terms you get cancel, and that's why they're not there. So the math geniuses decided, let's call this difference of squares, because that's what the shit's in there, right? That's y squared, that's 4 squared, then it's a difference. So if I have a difference of squares, that's how it always works. You break them up in half, plus minus, or minus plus. Yes, it's almost too nice to believe. So watch this. I was joking, I want a little Yoda math dude that says, complexity matters not. Because if I put a lot of shit, you ready? Here we go. 4a squared b to the 8th c to the 16th minus 25x to the 10th y to the 40th z to the 22nd. Right, there you go. Why, Jeff? How many terms are there?
2.
There's 2 terms. If it's 2 terms, it can only be squares or cubes, and we haven't talked about cubes yet. Can you cut everything in half multiplicatively?
Yes.
Totally, right? So then you just cut everybody in half, minus plus. I don't care how much crap I put into it. If I can cut everybody in half and it's only 2 terms, and it's a minus, it's easy. So what I get if I cut this in half?
2.
Yes, 2. Keep going. A. B to the 4. C to the. So I'm going to put the other half over here. So then if I started to FOIL, they would come back together. Aw. 2 halves. Okay. And then the last dude, what do I get when I break him up? 5x to the 5th, y to the 20th, z to the 11. So I put the exact same, the other half of it over here. And then I just put minus plus or plus minus, it doesn't matter. As long as, so you all agree with me that I would get a middle term right here, gross, right? If I started a FOIL, don't I get the exact same thing except it's positive? So the middle terms cancel. And I designed it so I get this because half of it's there and half of it's there. So of course when I multiply, I get a whole one. Oh. I always get students that freak out when I put a big ass thing like that. But you guys see how, sure, it's got a lot of stuff in it, but I don't care. I don't have to do much with it. I just cut it all in half. Okay. Now, I'm always curious. I use an obscure movie to describe part of cubes. And so when I say cubes, I mean a problem like this here. Do you see why I would call that a difference of cubes? Obviously, x is cubed. What's 27 if you break it into parts? Break it up into 3 parts. 3, good. Not 9, but 3, because I'm talking about multiplicative line. 3 times 3 times 3. So that's a difference of cubes. I understand a student thinking this is not right. That it should be something like x minus 3, x minus 3, x minus 3. Do you understand that logic? Do you see why a student would believe that? In fact, some of you guys are like, I do. But do you see if I start to FOIL this, won't all the middle terms not cancel? Would I get only these terms? I need you to understand, when I get x squared minus 3x minus 3x minus plus 9, I get minus 6x, and then when I multiply, I get even more shit in the middle. I need a bunch of stuff. I need a couple of things. I need actually 4 things to cancel. Do you see how there's 2 terms missing? We got an x cubed, we don't have an x squared, we don't have an x, and then we have a number. So I need a lot of stuff to cancel. Okay. So this is not good. Bam, get over. So what I try to show students is that the very first thing, if you notice it's a cubes, you put little dude, big dude. When I have squares, I could break it up 1 and 1. I can cut it in half. When I have cubes, what I do is I put 1 of each and 2 of each, so that at the end I get 3 of each. The little guy, do you guys see the little dude? Look at this little dude. He's tiny. You can only fit 1 of each in. What is x cubed? Break it up. X cubed is x times x times x. What's 27? So what am I going to put in the little guy? I'm going to put 1 x in there and 1 3 in there. And I'm always going to use the same sign in the little dude. Now if I put 1x there, how many more x's have to go there so I end up with 3?
2.
Yeah, the other 2 x's go here. I put 1 3 there, so over here I've got to put
2, so 6. 9.
no 3 times 3? 9. Do I get my minus 27?
Yes.
Do I get my x cubed?
Yes.
Yes. If I make that a plus even, that's better. Yes? You guys with me? All right, let me stop for a minute. I really want this to make sense. This is the method. This is the factoring form that most students hate because it's got more memorization. But the memorization's not that bad. I got 3 of everything, so I put 1 of each in the little guy, 2 of each in the big guy. So when I FOIL, they come back together and make 3. Why do I have room in the middle? What's wrong with me? Right? What'd you forget to do this morning, Jeff? So you all agree I get an x cubed. Yay, I got a negative 27. Yeah, don't I also get a negative 3x squared? Do we want negative 3x squared? Is that supposed to be part of the answer? Shit. So we get a negative 3x squared. So we get an x cubed, a minus 3x squared. What else do we get? Don't we also get a 9x? Do I want a 9x? And I get a minus 27. So right now, this can't be the answer because it doesn't multiply out to be this. It's got extra shit. So what I need, has anyone ever seen Pulp Fiction?
Yeah.
There's a scene where an unfortunate thing happens in the backseat. Okay. So later they have to call some guy. It's the cleaner guy, the wolf. He's got to clean the backseat and he uses soap. So that's going to come into play here in a minute. This guy, is everybody semi with me? So far, this is great. Because I get my x cubed and I get my 27, but I get extra shit, yes? This guy's job is to clean this away. Do we want these? I really want you guys to understand what I mean by that. Whatever this is, it better equal this. That's the whole idea, right? I'm trying to factor this. Currently, it's not equal to this. It's got extra stuff in it. Can somebody tell me, what would you multiply negative 3 by to make negative 9x so I could kill this.
Negative 3x.
Almost.
Plus
Yes.
three.
So if I put a plus 3x there, what did I just make? Negative 3 times 3x is
Negative 9x.
negative 9x. And look what else I got. What's x times 3x? Plus 3x squared. Didn't that cancel and that cancel? And watch what's really cool. What's in the little dude? What's in the little dude? A 3 and an x. And what did we put in the middle? 3x. It always works that way. Whatever the little dude has, you just multiply them together. Why does that have to be the opposite sign? Because what's this guy's job? What's his job? He's got to cancel. So of course he's going to have the opposite sign. Okay, maybe. Let's do another one. By the way, before I get too far away, do you see how that's the same sign? This sign is the opposite, and this sign is always positive. So, okay. Let's try another one. What you got, Jeff? Yeah, let's do that. 8's easy. So how many terms are there? 2. Can't be grouping, it can't be the trial and error and the surefire. It can only be squares or cubes. There's no GCF. What is 8 broken up into 3 parts? 2, 2, 2. W cubed is WW. So 8W cubed is 2W, 2W, 2W. Does anyone know what 125 is? 555, yes. By the way, being a math guy, it's kind of funny that we're near the intersection of the 8 and the 125. They're both cubes? Okay. Now I start to construct my little dude and my big dude. So what goes in the little dude? Little dude, big dude. What goes in the little dude?
2W.
2W.
Plus 5.
Good, same sign. So one of each. One of each. So of course what's got to go in the big guy?
2W squared.
Careful.
2 squared.
4W squared.
Oh, yeah.
So square 2W, you get 4W squared, yeah. And then what goes over here?
25.
25.
Good. The middle sign has to be,
Negative.
so it can do its job, right? Clean up the stuff I don't want. And then what goes here?
5.
What's this times this?
10.
Always. And the middle guy. So I always dislike using songs to memorize things for math because it makes it sound like you have to have the song to understand. So this is 1 of each, 2 of each, product in the middle. That's the closest to a song I'll get. Okay, maybe. So people, of course, this is the most disliked form of factoring because it's the one that requires the most memorization. But it's only this guy that really is kind of like out of sync. 1 here, the other 2 there. 1 here, the other 2 there. Because I had freaking 3 to start with, right? It's this guy that's a little bit off. Okay. So, with that said, let me give you this. I haven't given you guys this yet, right? I think I would do that. Oh man, I left myself none. Before I sorry. So, what I want you to do right now is to try out number 1. We haven't. Yeah, we did the other day. Number 2. Number 6. Yeah, just try it number 1, 2, and 6 for now. Call Christina or I over if you need some help. Hold on. Oh, greatest common factor. That would only be if each term had something in common. So if you have two terms, that's what this site's on. You have two terms, you have all these squares or cubes. Right? So can you cut everybody in half? Or can you cut everybody in thirds? I see. So watch this. What's 9 divided by -9?
Negative 1.
Yeah, and then they would match. No, you're taking a -9 out, right?
Right.
That's why -36 became +4.
Right.
And +9 should become -1.
Okay.
Yep. So when you take a negative out, both sides change.
Right.
Well, it's beautiful. I love that you stopped because some people just somehow do the last step.
And then, yeah. I was scratching it like that is an opposite.
Yeah. Unfortunately, I gave oh, looks good. Yeah, it's nice sign. X plus 9. X plus 1. You see that whole big? You're 81. So like the x and the x is together you make it squared. And of course 9 times what is 8? 9. Yeah. So with those, when you see the two terms, cut everybody in half. Multiply. So that you gotta end up with the same number as each, because that makes the middle terms the same and then you cancel. Oh, this is an exciting part of the video. I forgot to pause it. All right, guys, let's take a look here. Let's see. Okay. On the other side here, probably the most important part is this quick reference up here. The number of terms tells you what to try. You always try GCF. That could always be something. If there's something that all the terms have, get it the hell out the way. Do that first. That'll at least make your number smaller, all this, everything will be better if you get that out of the way. If there's 4 more terms, you group. 3 terms, you do the trial and error thing. 2 terms could be squares or cubes. So here I've got something. Is there a GCF here? Is there something that goes into both pieces? No, he's only got X's, he's only got 3's, 2 9's, whatever. So, no. There's only 2 terms, and you can cut both of them in half, so it's a squares. The minute you know it's a difference of squares, you really should say, under your breath, thank your favorite deity, whatever that may be. Because it literally is just cut everything in half. X squared, cut it in half. Plop, plop. What's X squared cut in half? XX. So you got X, X, and that's where X squared comes from. 81, cut it in half. 9, 9, and then to make the middle terms cancel. Plus minus or minus plus. Yes? Because multiplication is commutative. So 7 times 8 is the same as 8 times 7. So if you put X minus 9 times X plus 9, you're completely fine. Okay. Is that alright? So when you see 2 terms, it can either be squares, which is awesome, or cubes, which is a little worse. Okay. What about number 2? Is there a GCF? No, because 8 and 9 don't have anything in common, so it doesn't matter about 38. What do I have to do first? There's something in there that tells me what to do first. What's that first number?
8 squared.
It's 8. Is it 1? No, it's 8. So what do I have to do first?
Times 9.
Yes, I got to take it into account. I don't find factors of 9 that make 38, thankfully, because there ain't none. I find factors of 72 that make 38. Which still kind of sucks, maybe. So this is where your ability to break numbers into parts. The better you are at that, the easier this is going to be. Now I'm going to let you use your calculator, so you can just start doing 72 divided by 2, 72 divided by 3. Well, if you do 72 divided by 2, what do you get?
36.
36 and 2. Can that make 38?
Yeah.
Yes. So if you sit there going 8 and 9, that makes 17. Nope. What would it be? 3 and 24. Does that make 17? No. So does that make 38? No. So you get to 2 and 36. What's got to be true about them, though?
Both negative?
Good. They have to be the same sign, and to make a negative 38, they have to be negative. Okay. Now listen, guys.
I know this isn't like super intuitive. It isn't. You're not born. We don't come out and you smack me on the ass and I'm like, 2 times 36. No. This is not intuitive. This is not hardwired into us. But this is the bread and butter of most math-related stuff above this level. If you can't factor, you're going to be locked out of basically everything. Yes, Christine can maybe vouch for me. I mean, it's just everywhere. It's almost one step in everything. Okay. I'm not trying to freak you out. Just saying you have a lot of motivation to get this stuff down. If I see 3 terms, I'm hoping that first number's a 1, because then it's just the number puzzle. What 2 numbers do. If I see a first number not a 1, I'm like, damn it! I gotta multiply it and then start the number puzzle. Now, who remembers what to do with those 2 numbers?
Put it back in.
Huh?
Put it back in.
How?
You slide them back in place of the 38.
Kick ass. So you break up the 38, and it doesn't matter which one you put first. I just happen to do it like that. So if you turn these around, we'll end up with the same answer. It'll just look different for a moment. Yes? It's pretty weird. Are you guys with me? I could have put negative 36 first and negative 2 seconds. It would have still worked. Okay. The way I wrote it, though, what comes out of the first 2 things? What comes out of these 2?
2x.
2x, kick ass. 8 divided by 2. I had 2 x's, took 1. You could literally say this to yourself, maybe not out loud on a test or something. Right? You can just say this to yourself. I took that, then I got this left. I took that, I got this left. What is 2x divided by 2x? Okay. And real quick word about this. I'll get people that don't put that, they just put that. That is so wrong, because if I multiply this by this, do I get all of this?
No.
So another way to look at this is it's a placeholder. It holds the place of this guy. See it? Or better, something divided by itself is freaking 1, yes? Okay. What comes out of these 2? Now real quick. I think you guys all get that whatever little dude I get over here has got to be the same, yes? Do you see how the first number is positive? 4x positive 4, yes? Do you see how this is currently negative? So whatever I take out, I've got to take negative that out. So I make the first number positive, or else it ain't never going to match up. Okay. So what can come out of 36 and 9? 9. So I take out a negative 9. Negative 36 divided by negative 9 is? Positive 4, x. And what's 9 divided by negative 9? And then these are the same, thank the gods. And what's the last step I can do then? Yeah, take a 4x minus 1 out. And I'm left with 2x minus 9. And if you have time on a test or something, you just multiply this back out. Make sure you actually get that. Okay. How you guys feeling? So factoring is not intuitive, but it isn't crazy hard. It's just something you're not used to if you don't do it all the time. But it is insanely useful. It's everywhere. What form is number 6 in? Yeah. It's 2 terms. It can only be squares or cubes. And it's very obviously cubes. There's no GCF or anything, right? Come back. Over there. Okay. If I identify it as cubes, what can I put down for myself? What do I put down? Yeah, little dude, big dude, yes? Just humor me. I do that because if you got cubes, you remember, oh, this guy, I remember this idiot saying, little dude, big dude. This crazy dude told me to do that. It might prompt you as to what to do next, right? Because a lot of you guys, it's easy to sit at a test and just kind of get paralysis. But if you remember one step, that might lead you into the next step. What can I put in the little, what should I do? Actually, I should have done this at the very beginning. If you break 64x cubed up, yeah, you get 4x, 4x, 4x. And what about the other one? 3y, 3y, 3y. Do you have to write that down? No. If you do, will it help you? Yes. So what goes in the little dude? Good, one of these. Minus, same sign, one of these. Because he's just a little dude. You can only shove one of them in there. What goes in the big dude? 4x times 4x is?
16x squared.
And do you see how you get 64x cubed here? What goes at the end?
9x squared.
And do you see how you get negative 27y cubed? So you can kind of follow yourself as you go. And the middle term is the guy's going to clean up the other shit that I don't want. What's the middle term going to be in this case? You can do it.
12x.
12xy. That's too awesome to believe. Whatever the shit you put in here, you just multiply it, change the sign. So same sign, opposite sign, always positive. So, okay. How you guys doing? Do you guys remember doing cubes before, by any chance, anybody, before this semester? Somewhat? Are they better right now? I don't know.
You explained it a lot better than my last teacher.
Okay, I'll take that as a win. Okay. They're not intuitive. They just aren't. Of course they're not. If you're in STEM, you're going to hit a lot of counterintuitive stuff. Are you kidding me? Okay. By the way, just one more of these I want to do, and I've got the answer key for this I can give to you, but I would highly recommend you try these first and then you can check yourself. But I do want to look at this one real quick. Do you guys think that number 4 is a cubes? Do you see why somebody might think that? You got your 8, right? 8's a cube. You got your x freaking cube. But why is it not a cube? Because you've got everybody in thirds.
You take out.
No, the other one's only got 1x. And he's got a 50. Break 50 up into 3 parts. No, I don't want to. Right? Good. So, but what's going to save my ass? What should you always try first?
Greatest.
Yeah, greatest common factor. What number comes out?
2x.
Well, 2, and then I can take out an x. I like it. And what's left? 4. How many x's? I had 3, I took 1. 50 divided by 2.
25.
I had an x, I took it. Now, if somebody circles that and stops, you're going to lose points. Number 1, because I'm evil. Number 2, are you done? No, what's 4x squared minus 25? Can you go further? You guys see what that is? How many terms in it? 2, so it can only be squares or cubes. It's not cubes, right? Can you cut everybody in half? Can you cut everybody in half? So I'm saying this piece here. This 2x is done. He's just going to come for the ride. Can't you cut this guy in half? What would it be? 2x, 2x? 5, 5? Plus minus. So when I say factor, I mean factor completely. Right? So if you factor 18 and you say 3 times 6, are you done? No. It's sort of like, remember the prime factor trees? So when I say factor, I mean factor all the way down to its DNA. 18 would be 2 times 3 times 3. That's his DNA, yes?
Yeah.
Isn't 18 2 times 9?
Yeah.
Isn't 9 3 times 3? So 18 is 2 times 3 times 3. That is completely factored. Okay. Alright. So what I want to do, you guys we got the factoring workshop. We've got this here. You've got in the lecture book, there's an appendix that I always forget about that goes over factoring. It's got some problems. So if you go to the CISL, if you go to the Math Science Center, you can bring any of these things and have a tutor help you, have an instructor help you in the CISL. You have got to get your factoring down. It's going to be in a lot of different things. Okay. What are we doing? All right. What I want to get into today, and this is fine. The thing I've got to remind myself about this class, which is why I'm okay if somebody had another question about factoring, is we have a decent amount of time.
I told you guys, this is basically a pre-calculus and we kind of took a lot of stuff out of it. So we have more time to live with an idea. So if you guys ask, and by the way, I haven't said this yet, but one of my most important jobs as a teacher is to keep us on track. Is it your job to keep us on track? No, it's your job to not make us go off track. But what I'm trying to say is, don't ever stop yourself from asking something because you're like, I don't want to hold this guy up. No, that's my job. If I'm like, if I gotta go, if I'm like, we gotta go to the next thing, I'll tell you, come see me in my office. I can't answer any more questions right now. You guys with me? That's my job. You guys don't hold yourself back because you're worried you're gonna take up my time. You with me? It's my job to keep us on pace. Okay. I'm just always curious if anybody's like, I was gonna ask you, but I didn't want to. No, ask. Okay. See if that prompted anybody. No? Okay. So what we're about to get into, the section after this is going to be functions, but what we need to talk about right now are complex numbers. Has anyone ever heard of complex numbers, or has anyone ever heard of imaginary numbers? Yes? Yes, okay. Has anyone never heard of imaginary numbers? Or you're like, is that, when you hear me say that here, you're like, oh yeah, I knew you made all this shit up, Jeff.
I was like, why are we imagining numbers?
Understood. I just want to tell you guys this. Do you guys realize that every number we use had to be invented at some point? Like the symbol for it, the idea of it had to be thought of. You guys with me? The Babylonians, for a large extent of their civilization, had no symbol or understanding of zero. Well, they had an understanding of it, but no symbol for zero. They created a symbol for zero, and then their civilization fell. Right? Some guy was like, look, I got zero. Oh shit, we're all dead. Okay. So, let me see. When they first came up with the idea of negative numbers, people didn't trust them. So mathematicians back in the day, if they had a minus sign in an equation, they would add it to the other side to keep the negative from being there. We were freaked out by negatives. Yes? Nowadays, negatives are a normal part of life, unfortunately, like my bank used to tell me when I was a grad student. Negative numbers very much existed for me. Yes? Imaginary numbers were called that, and the name stuck. But they are not imaginary. They exist. Electrical voltage waves could not exist without the idea of imaginary numbers. For example. So, a really good question right now is, what the shit is an imaginary number, Jeff? So let me start off with something nice. Oh, did I turn you back on? Yes. When I multiply by -1, there's a wonderful visual way to think about this. What is 1 times -1? What is 1 times -1? -1, okay. So if I start at 1 and then multiply by -1, don't I take a 180-degree turn? Do you guys see that? That's a really weird way to discuss it, isn't it? Do you guys normally talk about multiplying by negative in terms of taking half a turn? No, okay. But do you guys see what I mean by that? So if I multiply by -1, I go 180 degrees. So if I start at -1 and then multiply by -1 again, where should I end up?
You get to a positive one.
And it's true. -1 times -1 is positive one. That's why I used to talk about when I multiply by negative, it's like telling somebody to turn around. And then if I multiply by negative, they turn around, then the two negatives cancel. Are you guys with me? Okay. So this is great, Jeff. What does this do for us? So then, if we realize that, visually, multiplying by -1 is doing a 180-degree turn, naturally we start to say stuff like, well, what the shit's a 90-degree turn then? Let me ask you this. If I multiply by a full -1, I go a half turn, yes? What would make me go halfway if I multiply by half a -1? Yes? And remember, we've done this earlier. Let me see if I can say this right. I want to do half of -1 multiplicatively. That's the square root of -1, correct? So, if I start at 1, and I go this much, I've gone the square root of -1.
Now, does anyone understand that the square root of -1 is not real? It's not, which means it's not a part of the group we call real numbers. It exists. It is real. It's just not a part of the group that we call real. Okay. I really want you guys to repeat. How do I go another 90 degrees? If every 90 degrees would be multiplying by the square root of -1, right, just like I did earlier, multiply by -1 is a 180. If I want to do it again, I multiply by another -1, yes? If I do multiply by the square root of -1 to get here, what do I multiply by to get here? Another square root of -1, yes? Okay. And that we can calculate, but let's see if that's true. If I do square root of -1 times another square root of -1, what is that? What's half of -1 times another half of -1? No. Let me ask you this. Go with me. What's the square root of 2 times the square root of 2? 2. Yes? You can think it's the square root of 4, which is 2, or I guess we can. So half of 2 times half of 2 is a whole 2. So what's the square root of 7 times the square root of 7? A whole 7. What's the square root of W times the square root of W? A whole W. What's the square root of -1 times the square root of -1? -1. A whole -1, yes? So, it jives. Did we end up at -1? Totally. So, we don't have a symbol for this yet, because that's kind of gross. I don't want to look at the square root of -1 because it freaks me out. Some of you guys said you've worked with imaginary numbers before. It kind of makes sense. What letter did we choose to represent square root of -1 with? Does anyone know? It's an imaginary number. Imaginary.
Is it
Imaginary. I. Okay. So what's really funky here, this is our first type of number that if I multiply it by itself, it's negative. There's no real number that does that, correct? I can't imagine a real number times itself coming out negative. Because if it's -4 times -4 is positive 16. It doesn't come out negative, right? But here, what did we just say I times I is? I times I is -1. And the beautiful thing is you can think of it visually like this. This is half of -1. We give it the symbol I because that's freaky to think about. We multiply by another I, we end up here. So let me ask you guys this. What is this place right here then? I pretty much told you. Let's see. This is how much? This is I, correct?
Yeah.
So that's where I get up to I here. So if I do another one, where do I end up? Telling that's a real circle. Where's this? What do you think? Negative I, kick ass. And it only makes sense. What do you think -1 times I is? Negative I. Yes? And what if I do another one? Back to 1. Yes? Okay, I like it. Maybe. This is trippy. Especially if you've never seen this before. My one dude I know for sure has never seen this before is shaking his head yes, which is good. This is so not intuitive. Yes? Visually though, I was never shown that. I was never shown that when I was taught imaginary numbers. I was never shown this. And that I was like, my God, that would have made it make so much more sense. Later in life, I actually figured that out. And I'm like, holy shit, there you go. Okay. So the most important thing at the moment is this. I squared is -1. Okay. So every number you've ever seen, we actually call it a complex number. We just haven't said that yet because we didn't know imaginary numbers. So complex numbers are things that have a real part, A, plus an imaginary part. So give me a normal number.
1.
Say again?
1.
1, amazing. So if I make A 1 and I make B 0, what is that? 1. So every number you've seen before today, if you've never seen imaginary numbers, were complex where B is 0. Okay. So real numbers are part of a bigger set of numbers called complex numbers. Complex numbers are just real numbers and imaginary numbers put together. Okay. That sounds like mad science. So an example of a complex number would be 7 plus 3i. What would you say the real part is?
7.
And what's the imaginary part?
3i.
3i. Crazy, yes? When we learn numbers, one of the very first things we learn after we learn numbers is adding numbers. So how do you think I would add two complex numbers? So if I had 7 plus 3i plus 2 minus 5i, how do you hope that works?
Add the part there.
Yeah, add like terms. So what do you get?
9
9
plus minus 2i.
minus 2i. Yes, that's exactly how it works. Thank the gods. So on one level, you can look at I almost like it's a variable, like it's x. Is it a variable? No, because I is specifically what? What is it? What's the value of it? Square root of negative 1. Kick ass. You with me? So it's not a variable, but it is a thing I don't know. So it acts like a variable. So that shit's easy as hell. Yes? I could have given you this problem before I told you what the hell I was. You would have done this, yes? Now take a minute and do this problem. Do exactly what you think it should do. Go for it. Oh wait. Oh my god. So this acts the same way as if I was just a variable, right? Now normally we would get this far and we would stop. But does anyone see the last thing I can really do? There's one more step I could take. If that was an X instead of an I, I'd be done, right? You guys with me? If that was an X, I would be done. Why am I not done? What's I squared?
I squared is negative 1.
There you go. So I is not a variable. It is a freaky thing I don't know. So it's like a variable because it's a variable. It's a number I don't know. But I is a specific thing. So I can do more with it in some cases.
Is it positive 15 then?
Do it again.
Does it become positive 15?
Yes, kick ass. So it'll be 14 minus 29i minus 15 times negative 1, which becomes plus 15, which becomes 29 minus 29i, which is neat. I wish I could take credit for making that happen that way, but I can't. It's just lucky. Do you see how the answer is in terms of a plus bi? Do you guys see that? A is 29, b is negative 29. Okay. So when I operate with complex numbers, the answer has to be a complex number, which means the answer has to be a plus bi. How you guys feel? If you've never seen this before, your world just got rocked a bit. Okay. I'm gonna push my luck. I'm gonna show you a video that talks more about the basics of complex numbers, and then maybe next time I'll have something for Christina to do. I feel bad. Today was just heavy on the lecture, and I'm sorry about that. So everybody got that down? I gotta remember to stop recording so I don't get copyright strike. I speak from experience. Let's see. YouTube. No, don't Google YouTube. Come on. There we go. All right, let me stop my video. Stay. There's one more kind of weird little dude. Actually, two more. What do you guys think about this problem? What would you have to be careful about with this problem? It's relatively straightforward, but there's one thing you got to be careful about. Yes, the negative's got to be distributed because I'm subtracting both of these things. Yes? These parentheses are not even needed, really. So I can say 2 minus 3i minus 5 minus 7i. And then I can just put my like terms together, yes? Now, here's the last problem we'll do today. And then we're done till next week. The last thing we haven't done is divide two complex numbers. And this is where we're going to have to remember something. I think I want to truncate this a bit. Yeah, we'll get more into this. So if I have two complex numbers and I want to divide them, that looks horrific, yes? Here's the trick. If I can make the bottom real, if I can make the bottom only real, no i's left, then I can divide and I can get a plus bi. I can get an answer, yes? You do this with radicals, and remind me, what is I? Square root of -1. So basically it is a radical, it's a type of radical. So just to kind of cut to the chase, if I multiply top and bottom by the difference of squares pair, like this, 2 plus 5i. Let's see what happens. So the top I gotta multiply out. I'll do that second. What do we get on the bottom? We get 4 plus 10i minus 10i. Good, negative 25i squared, yes? And do you see how these imaginary numbers cancel? And then this, what happens here?
Positive 25.
Yeah, so then I get 4 plus 25 on the bottom, yes? You guys with me? So did we make the bottom real?
Yeah.
It's only real on the bottom now. That's what really sucked the most about this original problem is it had some imaginary shit on the bottom. Imaginary stuff is bad enough. But this was dividing by it. Like, damn it, so this is a way to kill that. What do we get on the top? 8 plus 20i, 6i, 15i squared. So I get 8 plus 26i, and this becomes minus 15. Good, because I squared is -1. So then I get 26i minus 7 over 29. And if I want to go, is everybody kind of with me? A little bit? If I want to go one more step, I get 26 over 29i minus 7 over 29. Do you see how that's a plus bi? That is a complex number. That's the form it's in. Freaky shit. Now, what I don't like about the lecture book that they put together is they don't really make an emphasis on complex numbers. Do y'all agree? This is kind of meaty stuff. Okay, so later, when we start solving quadratic equations, remember quadratic formula? Does that sound familiar to anybody? Negative b plus or minus blah blah. Okay.
We're gonna get answers that are complex sometimes. We're gonna get answers that are imaginary, so we have to understand what the hell they are. Okay. I think that's plenty for today. That is plenty. So go out, have fun, and I'll see you next week. If you have any questions, let me know. Otherwise, I'll see you on Tuesday. I'm gonna go set up for my factoring thingamajig. Yeah, what's up?
Not sure. When were you expecting us to use the lecture book for this? Okay.
Oh, I thought I'd get to
Oh, okay.
functions, which are module 1.
Okay.
And I think I did point out that factoring is in the
Yeah,
appendix.
yeah.
So yeah, once we get to functions, that's module 1. Yeah, we just haven't gotten there yet.
For the homework, it's in the textbook, correct? So you buy the textbook and you just fill it out in the
Or
textbook.
you can view it online, right? There's
Yeah.
a link in the Canvas.
Yeah, but you
Yes?
basically, it's like a textbook you fill out though, basically.
It's like any normal textbook where you take a pencil and paper, right? Like old school.
Alright, thank you.
Yeah, and then you turn it in.
Alright.
Good.